today we're going to start Unit 2. We're going to skip a few chapters. We're going to start with the physics first. So we're going to talk about forces and motion today. So Chapter 11, Section 1, How to Picture Motion. Now before we can imagine what motion is, we need to know what motion is. So our definition is that it is anything in which the position changes. Okay, so with motion, you have to have a change in position. That also means that you have movement in relation to some sort of frame of reference. Now, a frame of reference is something that's necessary to describe motion, but what we call a frame of reference is an object or a system of objects that are not moving with respect to the object you're looking at. So let me clarify that. Let's say that you want to know or want to understand how you know that your mail truck or your mail driver has moved from your house to your neighbor's house. Well, what you can do is look at the objects around the mail truck. You can look at the mailboxes, the road signs. You can look at trees, other houses. You can look at roads. Any of those things that surround the moving object that are not moving, that's your frame of reference. There are two things that go into describing motion. There's the when, and then there's the where. Both of those are very important. So let's take a look at Section 2 at exactly what the where and the when are. So the first thing that we need to look at is position. Position is a term that I just mentioned. Position is what we consider to be the distance and the direction an object is from the origin. So distance and direction, that's your position. Now distance, we've talked a little bit about distance before. Distance is a length. It's the entire length of a pathway that's being taken, so between two or more points. Distance is going to be measured in meters for this class. So for example, if I tell you that you walk 10 meters forward and 5 meters back, your distance is 10 plus 5. It's the whole distance you've traveled. Now, because we're talking about meters, because we're talking about a number with units, we have what's called vector and scalar. A vector is a number with units, or a quantity that has a magnitude. Magnitude just means a number with units, and a direction. Whereas a scalar quantity only has magnitude. It does not have a direction. So if I were to say that you walk 10 meters, that's scalar. But if I were to say that you walk 10 meters north, that is a vector because it has direction with it. Time interval is another thing that you guys are going to look at. A lot of the time intervals that we're going to be dealing with is just the entire time, because when we start and stop stopwatches, or when we're timing something, we're starting at 0, and then when we hit the stop button, that's when we're stopping. Although you might have a time interval where, let's say, you leave your house at 7 o'clock in the morning, and you get to school at 7:45. 45 minutes is your time interval. It's the difference between those two. Now, displacement is very similar to distance. However, displacement has more to do with position, so it also includes direction here. So your definition is that it's the change in position, distance, and direction from where you start to where you end. So I'll say that again, from where you start to where you end. It does not mean it is the entire pathway. So this is different than distance. Now, the way that we're going to figure out what the displacement is through something known as vector addition or vector subtraction. So we're going to combine different vectors, or we're going to combine different displacements by adding or subtracting them. So if we're looking at a straight line, if they are in the same direction, so if you go north for 5 meters, and then you go north again for 5 meters, you're going north both times. You're going to add those. However, if you were to go in opposite directions, you go north for 5 meters, and then you turn around and you come back south for 5 meters, you're going to subtract those because they are in opposite directions. It's almost like canceling out. So here's a couple of examples for straight line displacement. Let's say that you are in a car and you go 4 kilometers to the nearest gas station. You fill up your car and then you travel 2 more kilometers in that same direction to get to the ball field. Well, your distance, you started here at 0, you went 4, then you continued and went 2 more. Your total distance is 6 kilometers. Now, as far as displacement, you started at 0, you ended at 6. You have 6 kilometers as your displacement. So for this example, displacement and distance are the same number. Let's look at a different example. Let's say that you are in that same car. You go to that same gas station that's 4 kilometers away. But then instead of going to the ball field, maybe you decide to turn around and go to the library. So that's 2 kilometers back from where you started. So we went, distance-wise, we went 4 and then 2 more. So we still went 6 kilometers. But now our displacement, where we started to where we ended, is only 2 kilometers. Okay? So opposite directions for displacement, we're subtracting. Distance, you will always just add up all the numbers. All right, let's move on and look at a little bit of different type of displacement. So we have what are called other displacements. These are displacements that do not fall in a straight line. They have different directions. So maybe you're going north and then east, or maybe you're going northeast and then north. All right, so you have different directions for these, and we're going to combine them by either graphing or by calculating. So when we're doing this, where we have different directions, we're finding what's known as the resultant vector. And that's just when you add up 2 or more vectors that are in different directions. So here's your example. Let's find our distance and our displacement for this example. There is a boy and he is walking home from school. He walks 1 block east. You can see the 1 block east down there at the bottom. We have 1 block north, 2 more blocks east, and then 3 more blocks north. So our distance, 1 plus 1 plus 2 more plus 3, he went 7 blocks total. That's our distance. That's easy to add up. But in this case, if I want to find the displacement, I want to know how far or how many blocks was it from right here, where he started, all the way up here to the top, where he ended. So this red line is our displacement. Now, in order to find displacement, we need to figure out a way to make what we're seeing here into a triangle, a shape of some sort, so that from your geometry class, you would know how to figure this out. So let's make this into a right triangle. We can move this vector, we can move this 1 block north over here and have a total of 4 blocks north. And then we can move this 2 blocks east down, and we would have a total of 3 blocks east. So that gives us a 3 and a 4 on each side. Now, because this makes a right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for the hypotenuse of this triangle. Go ahead and do that and plug that number into your notes. And that's it for today.